Thank you, everyone, for being here today. I'm actually super excited to talk about interoperability. You know, crypto's come a long way, over a decade of innovation, but there's still frontier technology that needs to be broken down. And a lot of the projects here today are actually going a step further, incorporating hardware alongside software, things like trusted execution environment, interoperability, and physical hardware itself. So by way of background, my name's Kevin O'Brien. I've been on the venture side in crypto for the last 6 or 7 years, invested into and helped launch and scale some of the most well-known projects in crypto. I'm also founder of Veridicity Ventures, which is a venture accelerator. And we work with exceptional founders and focus on token and internationalizing it. So let's get into it today. We have esteemed gentlemen here today. So what we're going to do is just do a quick round table and allow yourselves give your name, your role, and the project that you're with.
Yeah, sounds good. Hey, everyone. Thanks for joining us. I'm Josh from Solayer. I lead product here. And a bit of background on Solayer. We are the hardware accelerated SVM blockchain. It's an L1. We take a lot of hardware optimizations, splitting the consensus up, changing things to use different cloud technologies. Some of it uses NVIDIA's InfiniBand technology. Some uses RDMA offloading. And the main thesis is how do we use hardware to unlock the next quantum leap forward, right, in scalability. So we are doing around 300,000 transactions per second right now, and we're looking to push that to 1 million transactions per second. And we're looking at all sorts of use cases, particularly low latency, high frequency use cases.
Hey everyone, I'm Peter, founder of Relay, and we do instant cross-chain swaps and bridging across 80 chains, I believe maybe 6 VMs. And we have a focus on kind of consumer use cases where speed is really important. So kind of moving between any token on any chain within a couple of seconds. And so these sort of use cases like payments, onboarding into apps or chains, kind of consumer swaps, where people want to do it quickly, arbitrage, kind of moving between these sorts of opportunities. And yeah, so that's Relay.
Hi, I'm Yago. I'm one of the founders of BOSS, or BitcoinOS. BitcoinOS is a very, very ambitious but increasingly successful effort to bring programmability to Bitcoin using ZK proofs. So last year, for the first time ever, we were able to demonstrate the ability for Bitcoin natively to verify ZK with our operating system. And then on top of that, we've been building a number of technologies allowing developers to start building directly to Bitcoin and even entire chains to integrate deeply into Bitcoin. One of the biggest challenges that we had was that Bitcoin doesn't have native programmable tokens. And so we developed a system called Charms, which are programmable tokens for Bitcoin. And because Bitcoin is so minimalist, we discovered that Charms have a very interesting property, which is that the user can move them, port them from Bitcoin to other chains without going through what would typically be called a bridging transaction. In other words, they can transact in these tokens themselves. So sort of by mistake, we found ourselves in the interoperability space as well.
Nice to be here. Simon Berglund. I run business development and growth at Wormhole Labs. So on the lab side, basically, Wormhole entirely is a one-stop shop for interoperability and cross-chain. So anything from the basic messaging protocol to the actual SDK APIs powering developers and the front end. So we strive to be this, one-stop shop for interoperability and seamless cross-chain access.
Perfect. Thanks, guys. So you've kind of jumped into the first question, really, but I want you to kind of delve a little bit deeper. So, Interop isn't just about moving tokens or bridging anymore. It's like bringing in intelligence. There's RWAs. There's extension of digital assets as well. So how is your design continuing to expand interoperability, and how is that expansion of that changing how builders and users can compose across chains today? Maybe Joshua, if you want to kick it off.
Yeah, so I actually forgot to mention it earlier, but we did build the S bridge or Solayer bridge. And that's the first canonical SVM bridge. So anything bridging between Solana and SVM chains, that's where we can use the S bridge. And some of the unique features of it is that we kind of built a bridge that doesn't use an off-chain database. So usually that's a bit something that's more centralized that people have. That's a traditional way to do a bridge. But we have, because there's some things you can do on Solana. So we have specific proofs that we have on chain and it can just operate directly without having to store things off chain. And so it's completely permissionless. And some of the, I guess, making things more composable. On Solana, you can do like cross-program invocations or CPI calls. And the way we built the bridge is so that you could send a transaction instruction to the bridge to interact with a contract that lives on a different chain. So you can do like a transaction that compounds and, I don't know, does a DEX swap somewhere else. And because SVM chains all speak the same language and that data is being stored in the bridge proof itself, you can just fling transactions around and let them just do things across different chains without having too complex of like a messaging protocol and stuff like that. So that's some of the innovations that we did on the bridge side of things. And we're working with some of the other SVM chains as well, such as Soon SVM as well as Sonic SVM. And of course, this technology can be replicated across the entire SVM ecosystem in terms of making things more composable and more, I guess, multi-chain in that sense.
Very good. Peter?
Yeah, I think traditionally interop and bridges has been slowish for good reason. You know, you want to have your base layer be as secure as possible and like avoid global risk where if you move too fast between chains and there's a reorg on the origin, then you've just kind of created extra tokens out of thin air. And so I think for us, like, so it's really important to have that slow, secure layer. We're really focused on kind of like adding this fast interop layer. And I think that's really valuable for these more consumer use cases where they just want it to feel like a payment. They want to maybe not notice what chain they're using. They just have some money somewhere. They want to try a new app and they shouldn't have to care kind of which cult the app belongs to. They can just like bring their money and start using the app. And so I think like, you know, you're going to hear this a lot from me, but just kind of really focusing on speed because I think these consumer use cases value that. And speed is also just like one piece of UX where I think consumers who are using apps like Phantom or kind of like larger wallets where they pay kind of a high BPS fee to swap, these are users who are clearly kind of not super price sensitive. They really care about UX and convenience and ease of use. And I think that's, you know, what you're going to see kind of across the board if we want to have blockchains kind of power more on-chain finance and all these things. It needs to feel like these Web2 payments experiences that people are used to.
So I'd like to take a step back and think about the context of this panel, right? We're trying to solve a very significant problem, but what exactly is the problem? So in the beginning, we invented Bitcoin, we invented this blockchain, and what it provided was a unified settlement and ledger system allowing for transactions to trustlessly move within that ecosystem. Effectively, and one of the first things that people started calling it was the Internet of Value, right? And ultimately, what are we trying to do? We're trying to make value transfer as seamless and as secure, or even more secure, than digital information transfer. But we ended up in this very, very weird situation. Instead, right, that was where we were going, but we sort of took this left turn where instead of building that, we went and we copy-pasted this idea of a settlement and ledger system 100 times, 1,000 times, 10,000 times, mostly because it allowed us to launch an L1 token that we thought we could sell. And so now, instead of having a unified system, we've got this extremely fragmented system, and moving your assets, instead of being seamless, feels like trying to row a boat full of gold through shark and North Korean pirate-infested waters. And so billions of dollars get stolen every single year. And all of this is happening in an environment where crypto is primarily still focused on a particular type of user, which is a degen gambler, but increasingly more and more of the value and more of the drivers behind our industry are institutional money managers who are extremely careful and extremely thoughtful about how to manage risk, right? And they want to be able to manage risk. And so a whole bunch of different solutions have been developed for this, each with its own advantages and disadvantages, because they effectively represent trade-offs. So, for example, Wormhole represent an exceptional example of what maybe we could call classic bridging, where you have a set of custodians who take an asset and issue an IOU for that asset across some, multiple different chains. They've built out fantastic tooling around that, but of course there is the risk there that you have a sort of new set of risks and a new set of custodians who are holding your funds. Relay have taken a different approach. They avoid that risk entirely, but what Relay do instead is they can very, very quickly swap or provide liquidity for different assets across these different chains, right? So fast, no counterparty risk, but requires liquidity. And then Solayer, what they're doing is they are effectively providing a high degree of interoperability, utilizing proofs and light clients within an ecosystem, which is essentially the strategy that Ethereum as a roll-up centered ecosystem has taken as a whole, right? So each of these three different trade-offs, different strategies, and sort of we stumbled upon a fourth strategy, allowing users to sort of have assets they can move via ZK proofs without utilizing a third party. But now every time you move an asset, you of course are subject to new security assumptions on whichever chain you are on. No perfect solution. And I think this issue is becoming more and more important now, because it's in conversations that I am having, and I assume you guys are having as well. As institutional players are becoming more and more interested in this space, this is one of the key barriers. It's a barrier to liquidity, it's a barrier to counterparty risk, etc. And it's one of the things that is still keeping institutions in the what we can call CeFi or TradFi space. And so I'm not going to propose a solution because I've been talking for long enough, but I think that's a good way for us maybe to think about the problem that we're discussing here on the panel.
And just before we go to Simon, I think Edan, so why you're talking about this in such a comprehensive manner, the OS in Bitcoin, it stands for operating system. And I think this is a fundamental shift in technology in crypto, where, it was L1, L2s, sidechains, whatever, but they're kind of like isolated islands of technology. Everyone's used to their iOS phone and general operating systems. There's no reason why crypto can't have something like this. And I think BitcoinOS are positioned around this, and why morphing or merging a lot of the other technologies together can actually make it quite powerful. Simon, if you want to jump in.
So I mean, for us, as said, we have want to have the entire stack, and we want to make sure that entire stack have all the interoperability needs filled. So we're looking at our SDK APIs, for example, not only having support for traditional asset swaps, but also for, tokenized stocks, tokenized assets of certain kinds, so that when, projects or protocols want to go multi-chain, Wormhole becomes kind of the gateway for them, not only to power the traditional messaging, but also like any kind of interoperability action that they need, so that multi-chain becomes, empowering and not complicated. And speaking of that, the user experience, making sure that we abstract as much as possible for them. So we want to build our SDK API so that the actual developer can abstract as much as possible for the user, because in the end, they do not care what chain they're on. Like in general, they don't, right? They want to be where there's liquidity, there's high APY, whatever it might be. And we want to make sure that what we give to developers actually allows them to, abstract as much as possible. So that's a super important piece. And, not not compromising on security while still maintaining, speed, like, we're talking about on the relay side. So, for us in general, making sure that that entire stack that we're bragging about and talking about actually have all the interoperability needs, not only for today, but for the future. So yeah.
Great. So we'll start with you again, Simon, and we'll move down this way now. So this is more of a short answer. You can be quite specific or just to the point. So we talked about trade-offs in interoperability, right? There's always a trade-off somewhere. And what do you actually prioritize? So in your building, right, in the core development of your technology, what trade-off from a contrarian point of view, if someone brought it up, would you be able to defend, and why did you make that decision?
I mean, it's kind of a hard question, but I can take a good example. Like looking at the NTT framework, which is the native token transfer framework that allows for asset issuers to go cross-chain. Traditionally, like the speed at what a transaction can occur or a swap can occur has been depending on like the source chain finality, basically. But now we're introducing custom finality so that the actual asset issuer themselves can decide how quick a token transfer can occur. Obviously, that's a trade-off, but what we're doing is giving full customizability, which we believe in. And customizability is super important to actually drive like adoption for asset issuers to go cross-chain.
Yago?
So the biggest trade-off that we're making is that if you want to be able to maintain Bitcoin-grade security, so you can issue assets on Bitcoin, and then you can port them, what we call bridgeless porting. You can port them to a new chain, right? So you don't need a third party